Even a good morning or a good evening or a good afternoon. So whenever you're watching the video, so everyone give a like, share, and thumbs up to this channel, students. So electronics is. So I will be continuously uploading your passing package notes. So what is important for all the scheme students for electronics background mainly. So we are thinking of to start about the other branches too, but as of now, it is electronics branches. So if you have subscribed to the channel, you will be getting the notifications then whenever I will be uploading the video. So what we are talking about this in this video is about the important topics and important questions which will be coming in your examination for the network analysis, the 22 skill. Okay. So it is applicable for all the schemes. So they particularly focus on these concepts and these topics while making the question paper, as network analysis is very tough. So you need to focus on these topics. So these are the five topics which mainly questions arise. That is the mesh analysis, node analysis, star connection to delta connection, delta to star. So types of sources. So theory we can rarely expect in this kind of examination students, because this is a completely problematic subject. So what kind of theory they will be asking is briefly explain the types of sources and the networks. So there are current dependent sources, current independent. So those concepts you need to neatly explain along with the equations, and if there is a diagram, suitable diagram, you need to neatly explain and write. So this kind of question will be asked for 4 mark to 6 marks in your examination. So based on the marks given, so you need to write the answer based on the marks. The second one is make use the source transformation technique to find out the voltage V2 at node 2 in the circuit. So this will be for 10 marks. So you should know the correct proper node analysis, how to apply. So node analysis means you will be making use of the KCL. So how many nodes are there in the circuit, correctly identify, and based on that the sum of currents entering, sum of the currents leaving, you form the equations, see whether it is a current dependent source or a current independent source, and with the help of suitable transformation technique, you solve the problem. So there are many ways to solve the problem. So whichever technique which you feel easy, you solve the node analysis problem. Next, apply node analysis again. So same, you need to identify the current equations, and you need to find out what is the node analysis for the equivalent circuit. So find the equivalent resistance between A and B using the star and delta connection. So for star and delta, there are many formulas which you are supposed to use. So there are formulas which I've explained in the class. So here I'm not able to solve the problem because I have to tell all the five modules. So if you want any backlog courses, there are there. So you're welcome. So you can contact the details which were there in the description, and you are enrolled to the course. And the course fees is very minimal, students, which is very affordable. So next, find the power delivered by the voltage source in the network shown using the node analysis. So using the node analysis, you will be finding out the power. So power is equal to I square into R, or else voltage into current. So whichever you have the parameters, so use these two equations and solve for the power. So the next important topic derivation is derive the expression for star to delta and delta to star connection. So you need to derive the problem. So along with these problems, you even practice the mesh analysis, students. I forgot to tell you. So mesh analysis will be easy. So practice problems based on mesh analysis, that is, from you practice the problems from mesh analysis from current dependent and independent sources. So you will be using the KVL. So KVL you will be using for the mesh analysis, and you will be solving. So these are the important topics and important questions which will be coming for the examination from the module 1. So in module 2, there is theorems. So mainly practice on the superposition theorem, Norton theorem, and Thevenin. So in this superposition is like 50 percentage. Thevenin is like 50 percentage. Norton is like 30 percentage. It can come to the examination. Millman very rarely they are asked in the examination. Okay. So superposition, Norton, Thevenin, you practice. So superposition and Thevenin is very important. So the Norton very rarely they are asked, but you practice that. So using the superposition theorem, you need to find out the current I students. So you should be knowing the correct knowledge how to convert polar to rectangular, rectangular to polar in this kind of problems. Okay. So identify, so superposition theorem means, so the sum of the currents, which is which is equivalent to the algebraic sum of the currents entering that. Okay, so you will be using the superposition theorem, do one open circuit, one closed circuit, and try to solve because your two currents are given. So you do it. I think you will be knowing. So find the current Ix in the circuit using the superposition theorem. So you need to basically focus on the superposition theorem problems, and then next comes the Thevenin equivalent circuit. So use the Thevenin's formula correctly. So find out the voltage Vx. So they have given the terminals A and B. So so you bring down, use the Thevenin theorem, apply for individual box, and you will be getting an equivalent Thevenin. So because from getting the equivalent Thevenin, you can solve the problem for this. So find the current through the 16 ohm resistor using the Thevenin. Same concept is applicable over here. So you solve those and you will be getting. So determine the current through the load resistance in the circuit using the Norton theorem. So what is the current over here? So you need to identify using the Norton's theorem. Okay. So this is very important. So I have shared you the notes, refer those, and along with the classes I have taken. So you solve the problems based on that. So find the value of ZL for which the maximum power transfer occurs in the network. So this maximum power transfer is very much important. So I forgot to tell. So the maximum power transfer theorem is also there. So from this also there is a question. So Millman-Norman maximum power transfer theorem is also important. So use that maximum power transfer theorem. Pi is equal to I square into R. So there will be, so whenever RL is equal to RS, the load resistance is equal to the source resistance, the maximum power transfer takes place. So there is an example for those problems. So these are the important problems from the module 2. So coming to module 3, so you should explain the initial and the final conditions in the basic elements, that is the RL and the C. So you need to obtain an expression for a transient response of I of t of a series RI circuit whenever it is excited by the DC power supply. The next important topic is explain the transient behavior of R, L, and C. Next, explain the initial and final condition of RLC, that is the parallel and series. So the next, they will be giving you this kind of problems wherever the key is open, key is closed. So they will be giving the differential parameters along with the statement problems. So you need to solve those questions. So this is of also the same kind. So next, so key closing, key opening, those problems that you can expect in the examination. So next we will be solving the problems based on the, for the circuit shown, the switch is closed at t is equal to 0. Determine the current. So di by dt, d square I by dt square, and d square I by dt cube at t is equal to 0 plus. So for the circuit shown below, that is the VC of 0, find IO plus same this. So this concept is repeated for 10 marks. So the module 4 is very important with the initial and final value theorem. So this is a fixed question which will be coming in your examination. So then they will be asking you to find the Laplace transforms of the periodic functions. So based on that periodic functions, you need to solve. So next we will be solving the voltage pulse of a 10 volt and a 2-second duration. So RC network, find the current of I of t using the Laplace transform. This is also same. Find the Laplace transform of the periodic function. So using the Laplace transform, determine the current I of t in the current circuit shown. When the switch is closed at t is equal to 0, assume the zero's initial condition. State and prove, differentiate and S domain property. So the module 5 is regarding your parameters. So derive the y parameters in terms of a z parameter. So and you need to prove the following expression in series resonance, that is Fr is equal to square root of F1 into F2. You need to obtain an expression for the resonance frequency in parallel resonance circuit. So you need to define the ABCD parameters and obtain the ABCD parameters in the H parameters. So there will be a parameters question, that is H parameter, Y parameter question and all. So the next important topic is they will be giving you the important problems based on the RLC circuit. So they will be giving you a they might give you a circuit and ask you all the parameters, or else without the circuit, they will be asking you how to solve the problem. So these are the important topics from the module 1 to 5. So if you like this video, please share and subscribe, and even do invite your friends so that you will be notified whenever the new video is posted in the YouTube channel. Thank you. So if you are really willing to join any of the backlog courses of 21 scheme to 22 scheme, so description box I have written my name, phone number, contact details. So you are freely contact me through the WhatsApp, message me. So I will be responding you about the course details. Okay, students, have a nice day. Thank you for watching.